Hello and welcome to an Oxford MAT Livestream, or is it? Because the plan today is that we talk about any other sort of maths. My name's James. I'm broadcasting from the University of Oxford, right next to a building site. It's just hit 5 o'clock in the UK, which it seems for builders means times to start getting out the really loud hammers. Sorry if you can hear some sort of rhythmic and slightly tonal thumping noises coming from the building next to me. It's an enormous new humanities department, I think, so that's all fun. I will tell you about what the live stream is about today. I want to do all the normal stuff first, and I want to show you a thing that's on the screen as well. Hi Thomas, I'm good, thanks. Busy, but busy, but my job is turning back into my job. I'm not here to talk about my job. I'm here to talk about maths, and I'm talking about maths to you. I would like to know how your day's going today. Thanks for Tom for the excellent setup there. Well, I promise I'll tell you what we're talking about. I've got two topics in mind. I don't know if it's 2 hours today. It might be more of a 1 hour kind of thing. We'll find out. What is going on with that voting? Have you been coordinating? No, okay, right, okay. Yes, the voting is happening in Slido. If you're over in Slido, you can follow the event code #MATLIVE, that spells MATLive. If you're over there, you can post anything you like in a box labelled Q&A. It says Q&A, but we're using it as chat. I really like Slido because you can be anonymous. It's totally separate from YouTube, so you don't have to have a Google account. It's not linked to, it's kind of really obviously separate. And I like that quite a lot. We use Slido quite a lot around here. The count has for the Mac live stream across this summer has just gone past 5,000 questions. If you count anything like in chat, people saying hi, that counts. I can see some questions as well, which I'll do in actual questions, which I'll do in a second. I found out that we hit 5,000 because it turns out that that's the point where Slido start emailing you. Oh, I don't know if you can read this on the screen. I'll let you have a go at reading that, and I'll read it out in a second. I'll point at this bit. So we got an email from Slido, which I read as a kind of hooray kind of email, but also it turns out the reason that chat has been a little bit slow for the last couple of weeks is because we're reaching the limits of what Slido can achieve. So achievement get, you can't tell, but we are actually currently in a brand new Slido event with the same hashtag. I think you might notice that normally your answer to questions and stuff are underneath your entire history of everything you've ever posted on the Matt live stream. That's vanished this week because we are in a separate chat. And going forwards, I maybe have to do a separate one each week, so you won't have that lovely history of everything you've ever said. Cool. People are voting in chat about how the day's going. I can see about half the people on YouTube have made it over to the Slido. So good news, Slido. If everybody used Slido, we'd be at 10,000, and we'd probably have actually broken the thing. It does reveal to you a new way to troll me, which is if you can get 5,000 of your friends to all say hi, then we can overload Slido just by being polite and friendly in the morning. Right, okay, vote 5 stars is winning. I'm always looking out for people who vote 1 star or 2 star. I think it takes quite a lot to log into a maths live stream when you're at a 1 star day. I hope that some random bits of maths that I want to show you can do at least something. If you're at 1 star, then can't really go down from there. If you're at 2 stars, then I guess I could ruin your day. I'll try not to. Loads of people want the answers for 2023B. I'm not going to give them to you today, but I'm supposed to be working on a video, right? I'm supposed to give you a video of solutions. So it's not happening today. Maybe some point next week we'll get a video out with solutions, Matt, in some number of minutes. We're not going to spam the chat. Spamming it wouldn't be funny. Genuinely different people. Like if it's spam, Then I go to Slido and like, hey, we spammed you. That's not funny. Whereas if I go to Slido and I say, hey, my 5,000 viewers would like to, that would be funny. Good. There was a question. Other questions in here. What did I miss? What did I miss? I haven't asked them. I really wanted to ask them this question in particular. Was that email automated, or is that a real person sending it to me? It was written in what I felt was quite a human style, but you can't just write back to someone like, by the way, for my ego, do you send a lot of these? I would like, I'm not brave enough to ask them, but I think this is the biggest Slido event. 2023B is used for all the stuff that normal Matt is used for. We're getting data about what happens when you put people out with your answers after interviews are given. You don't want to keep overthinking it. Do you mean before interviews or after? 10 seconds video. I'm going to mark them. For example, if you did much better in the extra questions than the first paper. This is kind of the point. It's kind of the point that, well, I mean, we're going to present both scores to tutors and give them some information, but it's kind of the point that if you did terribly in the first one because of all the technical disruption, then you do the same one. You do the extra one, and you get a better score. That was kind of the idea. If you get a worse score, then that's not supposed to be a disadvantage. Anyway, enough math. My plan today is I want to tell you about Scrabble, but primes, and then I want to tell you, if I've got time, about eggs and graphs. That's my plan. I don't really know. It's about 30 minutes, maybe 30 minutes. If you're watching the replay, you can skip ahead about half an hour and see if I'm talking about eggs. We'll see. You can skip ahead and I'm still explaining Scrabble, and maybe skip another 30 minutes. Right. Interview. So in terms of Oxford admissions decisions, I don't want to talk about too much, but there's a timeline on the MAT website. If you scroll past the terribly large announcement, there's a normal timeline which says that interview invitations and not invitations go out at the end of November or the start of December. I'm hoping that we can still get those out at the end of November or the start of December. It might have to be start of December, but normal plan. Right, I'm from the future. The eggs are not here yet. Brilliant. Good. Okay, I'm not going to do the average. Yes, Miles is correct. I'm continuing because I want to do Scrabble. Right. Okay, I've got a spreadsheet for this. Real professional would have set this up beforehand, but I've got some external data that I want to call upon. How am I going to find my external data? Talk amongst yourselves. 2 seconds. There we go. It's this. Is it going to open on? Which monitor is it going to open on? Let's find out. Oh, I think it's opening on the safe monitor. Let's find out. Yeah, it opened on the safe monitor. Brilliant. Cool. It's not a sensitive file. I've got a cheat sheet. Right, good. Okay. So Scrabble is a board game. You might have seen it. Scrabble looks like this. It has tiles with letters on, and the letters are given numbers. So the letters might be given like numbers like this, and then the score that you get for playing the word is that you add them together. And this would be worth, well, the E is worth 1 point and the A is worth 1 point, and 1 plus 1 is 2, so this would be worth 2 points. Now there's a missed opportunity here, because the idea, of course, is that they put small numbers on frequent letters and large numbers on infrequent letters. So there's a Q tile out there that says 10 on it, and you get 10 points if you use that tile. And they've an attempt at matching that up to the kind of frequency distribution of the letters as they're used in the English language, so that you have these tiles you play. The E's and the A's and the R's of the world are worth 1 point, but the Q's and J's are worth kind of 10. My cheat sheet is partially to help me remember how Scrabble numbers work. Good. Okay. Partial information in the chat. Good. Okay. Yeah, and there's words like with a Q and a K in it, so it's part of the kind of Scrabble world. I could do a whole thing about Scrabble, but I won't. I have opinions about Scrabble, which I'll try and save for another time. Part of Scrabble is coming up with words that have a Q and a J in. so that you can score 20 points, like jockey spelt wrong. But part of Scrabble is also coming up with just really short words that fit in the spaces on the board. I don't love the fitting small random words into the board. There are words like this EA word. Is that a word? I'm not really sure that's a word. Like I don't really care if it's in the Scrabble rulebook. It's in the Scrabble rulebook. Maybe someone check. Yeah, let me know if this is a word by Scrabble purposes, not a word by my purposes. Okay. Also, they're missing a trick that they give some letters the same number, and they don't have to do that. So, what they could do instead is give each letter a different number. And my concept to make Scrabble better is to give every tile, every letter, a different prime number. I think this will make the game more fun. If we give every letter a different prime number, and then the score you get will be to multiply them together. Okay, so here 2 times 3 is 6. So in my version of the game, there's a prime number for each letter, and you get some points by multiplying them together. Okay, that's the kind of idea. EA is the name of the universe in Lord of the Rings. Now that's a good fact. I do like that as well. Fairness of additional math. I don't think I can answer your question about fairness of additional math. Partly because I'm not talking about maths today. We're going to do our best. Maybe I should scroll down to that. People who just want to hear about Scrabble, skip forward 20 seconds in the future. Oh, that sounds sad. In a loud classroom. There is an additional form. Please email us, and please email us so we know about it. I'd advise, in general, people. Sorry, catching what chat. A 24-year-old in Turkey. Hi. I haven't finished an undergraduate degree. You could apply for an undergraduate math degree, but I encourage you to. If you had some time out, I'd encourage you to try and get up to speed with school leaving maths again. Just revising it and practicing it and finding out about the fun stuff as well, of course. How fair is the ad maths on people who didn't take it? Yeah, so I thought this sort of thing would happen. Sorry, I found your question. People in the future, skip forward another 20 seconds, I found the question. Some people did it although they had no technical issues. So we have the special considerations forms, so we know what sort of technical disruption people had and said they did extremely well. Oh, brilliant. Okay, if they did extremely well, then they've done well at a maths test. They'll probably get interviews, and then we'll find out if they do well at interview. Others who didn't take it, so if you didn't take it, then that shouldn't be a disadvantage. Now, if you had disruption, then we are aware of that from your special considerations form. So it's hard for you to say that's unfair, that there's a process offered to everyone. It shouldn't disadvantage you for not taking the additional math. Like we have the contextual information there, but I think it was the right thing to do to give other people the opportunity to see the additional math. Some people did it although they had no technical issues. Okay, so I think we'd be aware of that. And if you're in this other case where you didn't do it and maybe you didn't have any disruption, I kind of feel like two cases there. If you didn't have any disruption, then you had a normal math experience, and you should expect a normal shortlisting kind of stage. And if you had disruption, then you should have been ideally invited to do the test as well. Shouldn't be disadvantaged by choosing not to do it and contextualise based on your special consideration. Interview ratio, something like that. Up for discussion. It's not set by. I mean, it's kind of decided by individual colleges, but with a departmental recommendation. We're getting too much back to my job. I was doing a fun Scrabble thing. People from the future, stop skipping. I'm going back to Scrabble. Sorry, everyone. Miles has put an email address in there. If you want to email me, then you can email me about the maths. We are on Not Math Livestream. Focusing. Right, okay. This is my idea. Primes and multiplication. I actually think it'd be fun. I think it'd be good. Here's the table of what I want to do. I want to do E is worth 2 points. Because E is the most common letter in the alphabet, in the English language, according to some random table I found. It goes like this. X, L. And then I'll put primes down here. N is 17. Also checking I'm getting my primes right. L is 23. And then I think this version of Scrabble is good, by the way, because it gives lots of points for using unusual letters, like more than 10. I'm already giving 23 points for any L's in it. And I think it really rewards long words, because long words just get you like all this multiplying by 2 at least. I think I prefer Scrabble if it rewarded long words and words with weird letters in. So in this world, EA is worth 6. You can get more than 6 just playing like the letter I, or playing just like a weirdest like N or something. These kind of short letter words are not worth very many points, whereas interesting letter words with 3 or 4 letters in are already worth like thousands of points. So they're way better. I guess kind of reweighting on Scrabble. There's also kind of dot down here underneath the L. Okay, so question, and this is multiply letter values for a word score. And we'll do an example over here. So the word, let's spell a small word, like riot is equal to, would be worth 5 times 7 times 11 times 13. I should have picked a small number. Why have I picked such horribly large numbers? Right, look, even the word riot is worth 5,005 points. That's amazing. Question then. Which actual word is worth the fewest points? And this is not Matt, right? Because what on earth does actual word mean? I think you know what I mean. Like, none of this, yeah, because it's the world in Lord of the Rings or something. Oh yeah, this is a good fact I should have used. This bit, good maths fact. Like, good thing on the show. Yeah, that's 1001. That feels like the sort of fact I should remember. Learning. Good, right, okay. The 26th prime. Oh yeah, by the way, so down the end of this table, there's a good question. I should give you more table. Yeah, I can give you the full table, I think. Is that 1, 2, 3, 4, 5, 6, 7, 8, 9? Yeah, I've got quite a lot more table. So, the bottom of the table, by the way, looks like, in the list I downloaded, it's ZJQ. Z is worth 89, J is worth 97, and Q is worth a massive 101 points if you have anything with a Q in it. And it's probably got a U in it as well, which is worth 31 points. I suppose I should tell you, in order for you to do this, you're going to need the full table, aren't you? So I should give you the full table. Okay, a little bit of rearranging so you can see everything at once. A. Oh, okay, everyone's got an A. Okay. A. Right, sure. So if you check some small numbers, this is upping this. Somewhere else, I have one of these and one of these, and now it looks less impressive, right? Okay. So I was writing out this table. I've shown you the bottom bit of the table. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I'm trying to work out if I can get this in 2 columns. I think I can get this in 2 columns. C, U, D, and then P. 31, 37, 41. Okay, and then new column for the letters after P. So part of this, if you wanted to play along at home, is you can get ahead of me by looking up somewhere, doesn't really matter where, a list of letter frequencies and a list of primes. Of course you can do better than that. Have I got 31 twice? C, thank you very much, good spot. D should be 31, C. C is 29. Just as I was saying, our list of primes, there we go, thank you. 43, 47, 53, 59, 61, 67, 71, 73, 79, 83. Okay, there's our table. Yep, sorry, they should not have been 31. It's because I missed the number 29, but I got engagement out of it. Look at those Slido questions. On our way to another crispy 5,000. Okay. I really like Slido. Good. I told them when I replied to their email to say, oh, yep, sorry, it started a new event. I told them, people asking these 5,000 questions really like Slido. Please don't ban us. Right. Okay. So one letter words. A, I think, is the first one you hit. There's I not long afterwards. In between, you have that discussion about whether EA, which is worth six letters, which is worth 6 points, is a word or not. I guess you should also consider AE. And I'd like the kind of smallest 2-letter word that you consider to be a word. Maybe we should just start working out what the possibilities are, right? It means the musical note E and it's valid. Are you going to accept all of? Oh no, I guess you're not going to accept R as a word. So 2 could just be E. 3, I think you can only be A. 4 would have to be 2 E's, right? Which I don't really respect as a word. You can tell it's not math because it's all about numbers I respect or not. So this is the first kind of interesting one. Or it could be EA or it could be AE. Hope that's kind of clear, I guess. Is E a Scrabble word? I don't love it. 7 would be I, which I think is a word, so that's good. 8 would be, well, maybe you tell me in chat. What's going on here? At. Thank you, Hayden. I think that's the first, uncontroversially, definitely a word. At, which is worth 36. No, don't hold me to that. 3 times 13 is 39. I have some history. I have some history with the number 39. Yeah, that's a good one. That's uncontroversial. I like this. We have a balance now between, on the one hand, small scores for things that I don't think are words, versus on the other hand, larger scores for things I do think are words. And ideally, we want to move these two bounds together until we find the smallest score for something that's actually a word. Maybe you think we're already done, right? Ray is a musical note, and now we're getting a little bit controversial. If you're telling me a word in chat, can you also tell me the score, just to make sure that we makes it easier for people to skim read and compare, right? And then here we get this Ray, which is like which is a word I say a lot. Maybe I respect that as a word. Okay. It's going to be bigger than at, right? Because I is bigger than A. But yeah, I like what you're saying. That's a score of 91 for that 2-letter word. I really want to stress again the 3 and 4-letter words are worth even more points. I don't know if it's more or less controversial if you go to 3-letter words. So 3 instead. Because I know that 2-letter words have a special role in Scrabble. There's like an accepted list of 2-letter words. Maybe by 3-letter words, people chill a bit and interested. Yeah, there's res 10. Ear is pretty good, and you can read it off the top here, right? Like EAR. Ear is worth 30, which is kind of, I think, uncontroversial as a word, and not worth very many points. Could you get a shorter? Could you get a lower score for a 3-letter word? I mean, maybe, but would it have to have some repeated letters? Ear for 30. I like as well. Yeah. So these 2-letter words, Somehow they're not quite doing it for me, I'm afraid. I like at and it, and then I have this kind of grey area, right? And ray, I guess, kind of, yeah. That's sort of hard to get excited about 2-letter words. I think this game might be more fun if we went to 4-letter words, to be honest, but opening a can of worms there. By 4-letter words, it's really not clear what I should be doing. Would you like the letters? The letters could be the same, and by that point, I think it's interesting to check. Program, check in a library of words from a dictionary, see anagrams. Yeah, do something like that, I guess. So I think if you implement that, if you want to live code it, go for it. But if you implement that, I think you'll find that the 2-letter words are all quite disappointing, and you should play this game with like 3-letter words or 4-letter words. In some sense, this is just a searching problem, right? The list of words is in a dictionary is a thing. The scoring system is well defined. You score all your words. Oh, look at these! Oh, look. Okay, so the thing has happened. This is the thing that I thought. Ear is better than ear. Oh, that is good. I like that a lot. That's just the sort of contribution I was hoping for. I thought EAR was going to be the best. I'm wrong. Ear, like this. Days of ear. It's worth 20. I like that a lot. That's currently winning for me for 3-letter. And then, oh, era. Oh yeah, but the 30 as well. 30 as well. Yeah, okay. ERE, very nice. For 4-letter words, something interesting happened. For 4-letter words, we had Ox is worth 913. Lovely. Was it 11 and yeah, 913. Brilliant. Okay. So I'm going to delete these kind of small words because I don't love them. Something interesting happened at 4-letter words. People suggested. I saw in chat. Tier from Thomas and rare is a little bit better, isn't it? What am I going to do? Tear. I saw from Anonymous. Area is a little bit better. I agree. When are you going to hit us with the unexpected maths, James? I know. Rare. Brilliantly. Okay. Unexpected maths. So maybe something you've been taking for granted along here, or something that's happening, is that if 2 words have the same score, what can you say? What can you tell me if 2 words have the same score? Yeah, so people are playing around with these 4-letter words that use some of these. We've got rate, which I'm going to put in this one over here. I should work out what these are equal to, by the way. Sorry, the thing that flips up is me opening a calculator, which is it's been a long day. I think these score 390, whereas area over area is worth 3 times 5 times 2 times 3. It's worth 90. It only says yeah, same letters. Yeah, then they are anagrams because of unique prime factorization. And I learnt about this trick as a way to find anagrams. So let's think about that challenge quickly. You have a dictionary of words in your computer, and you'd like to find, you pick one particular word and you'd like to find others that are an anagram of that. How you explain how to the computer how to do that, you might say, well, analyze my word first, find out how many A's it's got, how many B's it's got, how many C's, D's, E's, and so on, and keep track of all of those numbers. And then, oh my goodness, go and look at every other word and see how many A's, B's, C's, D's, E's it's got, and compare the two. And if they match up, then you're good. Alternatively, you could say something like, take my target word, put the letters in alphabetical order, and then take every word in the dictionary, sort the letters, and compare the strings. You could do tricks like that. Or you could do the kind of nicer thing where you assign point values to all the letters using the primes. You multiply them, like we've been doing. That operation is much easier. You don't have to do any sorting. You don't have to keep track of a long vector of things. You just do some multiplication. You assign that number to each word, and then you just find the words with the same number. And this is consists of the same letters. There are the same number of letter types from each of its sort. And this is a really efficient way of storing the data of how many of each letter do you have as a number. We can do a little bit better though, because this gives you a way to store other sorts of data. Yeah, so frequency order is not, people don't normally do that. I've put it on to make it a little bit more Scrabbly, but a little bit more Scrabbly. Frequency order means that the numbers aren't too big. It's a bit daft really, but most people would use just alphabetical order. Yeah, if you were writing in one of these. Yeah, there are some scores we can't get with the alphabet, but that's a limitation of our alphabet, right? What if our dictionary contains a word like cafe with an accent on? Then that's kind of awkward. I'd need to put it like on the end, right? And maybe I give up on frequency analysis and I just do these in some sort of order. But there's a general maths idea hiding here, which is that if you take finite length vectors, and this is the thing we've got, so the word area is kind of 1e, 2 a's, and then 1 r. So if you take vectors with, what do I want to put in here? Positive natural numbers, positive integers of arbitrary finite dimension. So you have things like, so here I'd be imagining this word as like the vector 1, 2, 1. Oh, I'm underneath the chat. There we go. For 1e, 2 a's, and 1 r. But I could also have a word with 4 different letters like rate, which I believe was t was, where was t in my? Now I regret not putting them in alphabetical order. 1, 2, 3, 4, 5, 6. 2 to the 6th thing. So I have 1e, 1a, no r's, no 4th letter, no 5th letter, and 1 6th letter. This is kind of the data, by the way, that you're, if you just counted how many A's, B's, C's there are, this is kind of the data that you're storing. Do a little bit better. We can go to arbitrary finite dimension. So that means a vector that stops, but you could have as many things in here as you like. You've decided to keep going using other letters. So after Q, you can keep going to fit in words like cafe, so that we can get this like 103 thing. Yeah, so this person in chat. Some scores we can't get like 103. Can now, if I'm extending this to have more letters in arbitrary finite dimension. You can map those to the positive integers. Woomph. By doing this trick. 2 to the first term, 3 to the second term, 5 to the power of third term, and so on. This is a general trick. If you need to kind of compress down your vectors that could have arbitrary finite length with integer components, and you need to compress them all down into the integers. You can do that by interpreting the numbers as powers. So it's like literally you read off rate, and this is the way that our scoring works, as 2 to the 1, 3 to the 1, 5 to the 0, 7 to the 0, 11 to the 0, 13 to the 1. That's a way to embed your vectors of arbitrary finite length into the integers. Yeah. Is it 1, 1, 1 at the beginning? Oh yeah, sorry. Sorry, there is an R. Yep, good correction, thank you. There's the R. Whoops. K, yes, please email mat-info. I think we're distributing something at some point, but please email mat-info. Sorry to hear that as well. Sounds terrible. This is quite nice because it feels like there are loads of these things, but actually there's not that many. If you need to work through these things in a systematic order, you could just put them into the integers and then go through one at a time. If you needed to prove that they were countable, you could map them into the integers, do them one at a time. So that's all good. I know some puzzles, which I won't do now, because spoilers, the answer to the puzzle is interpret the thing in the problem as vectors with positive integers of arbitrary finite dimension. And the problem feels difficult because of the arbitrary length of the vectors. And then keep track of them by converting to the integers. I'll give you one, which is the clicker problem. So the clicker problem is this. You've got people coming into a room. What do doors look like? Doors look like this, and you've got people arriving. And your job, this is you. I don't know, I was about to draw a wizard hat, I don't know why. Chat, you're a wizard. You're a wizard with a little clicker. You know these machines, the ones with a little ticket, little thing you press, and it's got a little display that kind of rolls over like that, so that it tells you the next number. This allows you to do your job, which is to count the people in the room. Okay, with me so far? Here's the problem. Clicker problem. So your plan is the people are going to come into the room and hang out in the room, and you're going to count them on the way in. Good job, you have just the tool for the job. You click the clicker every time someone comes in, and the number goes up. And then you have new job. Also, keep track of how many, and then I've started, so I'll continue, how many wizards are in the room. You only have one clicker, and it can only go up. So you've only got one clicker. It will obviously be easy if you had two clickers. You could dedicate one of your clickers as a special wizard clicker, and you'd use the other one for muggles. But you've only got one clicker. So how can you keep track of the number of people and the number of in particular, the number of wizards inside the room? Okay, over to chat, I think. Let's see. Do the cookie. I gotta do the clicker problem. I've kind of already. I just said cookie clicker because you put it in chat. Implying it's like Inception, putting my words into my mouth. Ooh. Oh my goodness, Miles is telling me about monoids. Let's do the clickers. Let's do the clickers for now. Clickers for now. How are we doing? We're live? We're live. Good. Realised that people from the future have just jumped in and found not the eggs they were hoping for. Yeah. So first idea, I like this. First one in. Let's get a couple more. Each wizard is worth 1,000,001 clicks. This protects you. Except, of course, if while the party's going on, you look at your clicker and realise to your horror that it says 2,000,002, and you've got no record of whether that was 2 wizards or a lot of normal people. You probably know, but I guess the maths version of the problem is to do it just based on the number. Multiply 2 for each muggle and multiply by 3 for each normal person. Right, okay, so then the hard question is, does that work? The hard part of the question is, you've got an interesting proposal. Does it work? I think it does. A person walks in, if they're a wizard, multiply by 3. Yeah, and maybe you do both, to keep track of both, or don't really mind. Yeah, I think that's good. So you've got to do quite a lot of clicking, but you try to keep track of storing. And you see the tricky thing is you've got to keep track of the number of people, but also the number of wizards, which feels like a vector of length 2. Number of people, number of wizards. But what you can keep track of is 2 to the power of people, 3 to the power of wizards, and then you're fine. So that works because of prime factorization. Yeah, yeah, they're independent, and they always make the number go up. So that's good. So then, other versions of the clicker problem. Because this, once you've seen the answer, oh yeah, 2 to the P, 3 to the W, once you've seen that, you think, well, actually I've got some space, right? I've got space for more data. There's loads more primes, for example, loads more numbers. So, for example, I hope you can tell if there are muggles and wizards and also dragons or something, what the dragons look like. It's not a dragon, that's a kangaroo. Little one in the pouch, there we go. Wizards and muggles and kangaroos, then that's fine. You just do like 5 to the power of, expand your vector a little bit. You 5 to the power of kangaroos or something. You keep track of that as well. Ooh. Oh yeah. So extracting this data does involve factorizing the numbers and maybe some logarithms. Yeah, we've got to use whole numbers, right? Okay. Yeah, the clicking is pretty bad. The original, so the original version of this that I saw was a real life problem that somebody I know was given a clicker, told to keep track of 2 different numbers with the clicker, and not sure how to do that. I'm not sure what the hardest version of the clicker problem I've seen is, but I've asked this to some other people and they've come up with different variations. One is like, so maybe the hardest version I can think of, and I'm not certain this works, but something like where you allow the people to also leave. Count the people in the room plus leaving the room. Can you keep track of the number of people in the room? Your clicker can't go down, and that's fine. You just keep track of the people who are in there and the people who have left there, remembering you're going to factorize the number into 2s and 3s and then subtract. Can you store a log of? So I think I haven't really thought about this version at all, but can you store a log of what order arrivals and leaving, what order arrivals departures happened in? So this idea, counting the people entering and counting the people leaving is just like 2 groups of people, so that's fine. What if I ask you for the order that those things happened in? I'd like to know, right? If 20 people arrive and then 10 people leave, and then 20 more people arrive, it feels a little bit different to me than if they all, like, there's just one person getting in and out, in and out. Maybe you can keep track of that. My vectors, I guess my vectors are horizontal and they're actually coordinates or something. I don't really mind. Vectors are normally stacked up. I am extremely limited on board space, and I'll do whatever it takes to show you a vector-like object. In fact, maybe it's this transpose. There we go. Put a little T there. Oh, but now it looks like a power. Anyway, good. Right. I said I'd talk about eggs. So I think my plan is to let you talk about the clicker problem for a minute. I'm slightly ahead of you. If you've been looking at live stream for 45 minutes, it's time to blink. Remember to look away from the screens. Remember to drink water. It'll let you tell. Yeah, multiply by a new prime. Yeah, it's something like that, right? Every time a group enters or leaves. As long as you decide, you've got so much. You've kind of got so much writing space in these exponents of primes. Yeah. How are you going to keep track, Thomas? You've got to keep track somehow of whether that multiplication meant somebody arriving or someone leaving. I reckon you can get away with it though. I should say, in all of these puzzles, we're imagining finitely many events happen, so you don't run into this problem that infinitely many people arrive and your clicker runs out of numbers. Can you figure out if we should extend this solution or come up with something new? So I guess I'm trying to extend the solution at the moment. I'm trying to push it as far as it will go. So far, the thing I've spotted is the ones that we've been thinking about. It's pretty clear how long the vectors are. There's no capacity for, oh no, we wanted to store a lot of information. It is kind of clear how much information we're storing, like the number of 1, 2, 3, the number of this, that, and the other. Whereas this kind of log of arrivals and departures, so there's like arrival, departure, Dad, feels like it's sort of harder to keep track of, because if there's more people, that's more data. That's a longer string. I've tried to design that so it feels a bit more like a vector coming in. How many? Yeah, so at the moment we only know how many of people and wizards. We don't know what order they arrived in. So maybe if you want to keep track of the arrivals, be like, hey, wait, all the people turned up really early, and all the wizards turned up really. No, wait, a wizard is never late. All the wizards turned up really early, and then the regular people turned up afterwards, plus one wizard, and that would be fun to keep track of. I think if we could manage to work out how to do it. It needs to be the case that whenever something new happens, the number gets larger as well. If 3 people, 2 goes out, then oh right, okay, so you're sequencing. Yeah. Okay, right, I like this sort of thing. And I think I saw something similar earlier. If you said the same thing and I missed it, I'm sorry. Change primes every time it changes from people going in and people going out, or people and wizards in my new version over there, so that you remember that 2 to the 3 at the start means 3 people arrived, and then that 2 means 2 people left, and then 4 people. Yeah, and that gives you a sequence where you're kind of interpreting this as like 2, 1, 1, 1, and then that's your exponents. And every time a new event, and that new sort of grouping them together, every time a new event kind of happens, you're using that as the exponent. Cool, and you're not going to run out of primes. That's the punchline I wanted to get to. You've got infinitely many primes, so you can store a lot of data. Every other prime for an entry. Yeah, I think that some of these are equivalent in terms of how you allocate storage space. It feels really computer science as well, right? Like you have this infinite tape that you can write to, but you can't erase. So the people leaving is supposed to make you think, oh no, I need to erase the data, but really you can just write more data provided you saw it coming. Anyway, good. Okay, I think that's event n multiplied by p to the k, where p is the nth prime and k is 1. Oh, yep, 2. Yes, I love this. Look at this. For event n multiplied by p to the k, where p is the nth prime to keep track another thing just happened, and then K to keep track of what it was. When wizard enters, person enters, dragon enters, the wizard goes out. Yep, cool. So you're prepared for any finite number of events, and those events could be a group of people arriving or leaving. Yeah, cool. I think the concept of event has been really helpful in this, the kind of bunching together of all these different ideas we're describing. Cool. Okay, I think we're now at capacity. I think we've now pushed up against stuff. Although part of the fun is to imagine doing this again, right? So maybe these are numbers. After the map, maybe these are numbers. Maybe we put them in another vector. Do it again. Abstraction. Right, good. Okay. I first learned, so full credit. I first learned about the idea of using primes for anagrams. This idea that you use your prime numbers to keep track of the counts of separate letters. I first learned about that yesterday on a live stream that I watch. You're watching a maths live stream, and separately I watched this other one. It's called Finite Group. It's got a Patreon and a Discord and stuff like that, and it's got 4 hosts who are Katie Steckles, Peter Rowlett, Sophie McLean, and Matthew Scroggs. And they do live streams, Discord chats, and just generally people talking about maths and stuff. They're really cool. I said I'd mention them in exchange for talking about primes for anagrams. In particular, it was Peter yesterday. It was Peter and Katie on the live stream, and Peter Rowlett was doing some sort of live coding to implement the anagram solver using primes, which I thought was neat. Good. Okay. This is what. So, partly I enjoy watching other people's chill math streams. I enjoy doing chill math streams. We're going to do more stuff like this. So, Finite Group is operating at the moment. If you want to see other mathematicians talking about fun maths, on this channel, quick advert, we're going to be back in January for Oxford Online Maths Club, which is also chill maths. And in my personal life, I'm also running a separate Twitch live stream as well. And we're promoting all the live streams today, of which I'm on 2/3 of the ones I've promoted. Right, good, okay. Good. Make a new language for 9 letters. Then when you need to write a note for yourself, multiply. Sorry, Rowan, this is brilliant. This is going straight to the top. Make a new language for yourself with only 9 letters. Then when you need to write yourself a note, you multiply by a prime that begins with each number. That's amazing. That's really good. And then you just read off the first digits, and that's your message. That's lovely. I love the idea that you're just writing out your notes, like, oh no, another wizard, and then translating that into, right, a lot of clicking for that one. Brilliant stuff. Excellent attitude. Right, yeah, Oxford Online Math Club. Is there a time to open those Twitch streams? Right, okay, so Finite Group. So Finite Group is on Discord live stream, Discord and YouTube. And they're still working out their schedule. They're trying different things, but it's roughly monthly. I think these are all cool people. I'm going to recommend it again. There we go. Oxford Online Maths Club is in January. It's going to be weekly at 5 PM UK time, just like this one. It's kind of the same sort of show, but it's not just me. It's more likely to have friends and undergraduates and students and other people around showing you some maths. In my personal life, I'm doing Chill Maths, which is the name of my Sunday. This one's Thursday. I didn't say the day of the week. There we go. Which is a Sunday 2 PM thing on Twitch. You have to look for me on Twitch. Yeah, Steckles and Peter also do a maths podcast. Katie does a lot of stuff with Matt Parker. If you've seen a Matt Parker video where they've built something enormous, in a maths festival or something, then Katie was almost certainly involved as well. Sophie does, or is part of the team that edits and Matthew as well, actually. Sorry, these two on the right are part of the team that does Chalk Dust magazine. Chalk Dust magazine is free. It's not behind a Patreon paywall Discord sort of thing. Chalk Dust magazine is also really funny. I like it a lot. It's got maths articles. It's just good. That's what it does. So these two are part of the team behind that. Sophie's just starting a PhD. Matt Scroggs has done various things. Matt was on QI at one point, showing them a collection of matchboxes, matchboxes that play noughts and crosses, tic-tac-toe, which is very cool. The project there is called Menace. I think if you search for QI Matchbox Menace, then I think the clip's on YouTube somewhere, and you'll see Matt playing matchboxes. Katie's done loads of stuff. Peter Rowlett has done the primes for Anagrams that I've done the shout out. You should find out all about all of these people. There you go. Shout out. Yeah. There's not that many maths people. Any two cool maths things that you've seen have maybe got someone in common, and it was maybe Katie. Right, good. Okay. Katie does a lot of stuff. Brilliant. Okay. Together, most of them, hang on, people on the left organise a conference. This is less relevant for you, but Peter and Katie also organise Talking Maths in Public, which is a kind of conference for people who do what I do. Right, cool, I'm getting a little off track. Mathematicians is quite finite. Good, right, cool. I promised eggs, so I can't leave until I've done eggs, even though it's 6 o'clock. Them's the rules. Okay, I think I've talked about this problem before, but I'm not sure how much of it I've talked about, and I think I get a completely different set of viewers every year, so I think it's been long enough that I can talk about it again. It's the egg box problem. Egg box photo problem. Here's the problem. You've got an egg box with 3 spaces for eggs, like this, in a row. This is you looking straight down on your egg box, ready for breakfast. And it contains 2 eggs and a gap. So if you take a photo of this, then I think for photos I'm going to have to do some sort of copy-paste thing. Take a photo of this, you can record what it looks like. Oop. Here's the game. Move 1 egg at a time, 1 space along at a time. No jumping or skipping spaces or putting 2 eggs in the same space or anything. Take a photo after each move. Can you get photos of precisely all three? What are these? Kind of arrangements, I suppose they are, or a kind of permutations or anything. All 3 arrangements of the eggs in the box. Without repeats. It's quite a wordy problem, right? Let's try and move stuff around a little bit to fit it on screen. So like a move is something like you move an egg like this, and then you take a photo, and then you move an egg like this, just 1 space. We're being very careful with the eggs. No jumping, no leapfrogging way over the top. No leapfrogging, no jumping. And you take a photo, I've now got all three of the arrangements. The eggs are indistinguishable. They can't move. They actually can't move past each other because of the no leapfrogging thing. So, but yeah, they're indistinguishable. Yeah, rubbish egg box, just 3 spaces. Yeah, so there's an empty space. If you like, it's an empty space that's moving. And the answer here is yes, and this sucks. Yes, and this is boring. So, to make it more interesting, I would like to change the number of spaces and the number of eggs. I'll keep the structure, this long, thin egg box. I've tried thinking about other shapes of egg box too, and this turns out this problem is already hard enough. Doesn't look it yet, but this problem is hard enough. So let's try the case with 4 spaces and 2 eggs. So slightly larger egg box. And again, the challenge is to start, and I suppose I'll let you start with the eggs however you like them, probably on the left. How do you like your eggs in the morning? On the left of the box. So that can be your first photo. And actually there's more than 3 now, aren't there? This said 3 before, but this is now going to have to say n choose r, where n is the number of eggs, or n is the number of spaces, sorry, and r is the number of eggs. And the answer is now, I claim, maybe, and this is weird. Okay, photo problem. So we're going to move an egg, and already with 4 eggs it's slightly better, because you move an egg, take a photo, and then you've got a choice. You've got a choice now, because you could move this egg 1 space, or you could move that egg 1 space. You shouldn't move it back because we're trying to get all the photos with no repeats. You see, that's why the no repeats rule is there, so that you don't just you can't go back. You've got to explain. So no repeats. I don't want to see the same state twice. If you're allowed to see the same state twice, then it's kind of easy. It turns out you just shuffle the eggs backwards and forwards, and they're always fine. Okay, so maybe we move this egg over. That's all right. But I feel a bit weird. Like there were choices there, right, about what to do. And then maybe I've still got so 4 choose 2 is 6. So maybe I'm okay. Maybe I can keep going and try and get all 6 of these positions. The photos, by the way, provide this kind of stop motion image of how the eggs moved around. You can see I've been moving that egg along each time. Probably time to move the first egg now. I think I'm doing okay. So if I move this one like that, then I get to the end. But I've missed one, right? Let's get they've gone over the text, so I'm going to move that up. I've missed an arrangement, can you see? Bother. That's only 5 of the 6 possible photos. I've got to find a way to say this where it's not taking photos of them. The idea of taking photos of the egg box always makes people feel weird. I'm trying to go through all possible states. I've missed one. Truly excellent proof that Slido only allows 5,000 comments. So you do want to start start with all arrangements and try to match them up, order them so that no eggs are jumping. Yeah, so the sorting problem. I guess the one that I'm missing is the one with 2 eggs in the middle. I haven't got that one in my map. This is a bit irritating. Thomas has got a plan for me. Okay, move the left one back. Move the left one back. I'm being really thick. If I don't want to move the left one back from the way it just moved, but I'm not sure that's what you mean. Yeah, Zoe's right. Moving an egg is like moving a blank space. The egg has to move into a blank space, and it leaves behind a blank space. So, in a way, the blank spaces also form a sort of similar looking path, where the blank spaces here form this different route around. So, time to drop some maths, because I think that's useful. The way I've been thinking about this problem is in terms of graph theory. So let's just take a note of where we got to here. Sorry, we did not see this. But we had some choices along the way, right? Some choices. We got an odd and even thing going on in chat. Yeah, so we got these states. We got these 6 states, and the important thing is to lay them out in a sensible manner. For me, I think I want to call the positions of the eggs. So I want to give the positions number 1, 2, 3, 4, and I want to keep track of where the first egg is. I'm going to call the first one eggs, even though that sounds like eggs. And I'm going to call the second one's position y. So we start at x is 1, y is 2, and then we move to y is 3, and then x is 1, y is 3, and then we move to x is 1, y is 4, and then x starts changing as well. And that's nice because then you can put it on an XY graph. You can keep track of the states. So this graph is a little bit funky. This graph is going to keep track of the states for me to say where could the eggs be. Now, x is always on the left of y. They can't jump over each other. So x is always a smaller number than y. I guess if this is 1, 2, 3, 4, move down 1 square. 1, 2, 3, 4. Then this would be x is 1, y is 1. Oh no, that's banned. They can't be in the same space. But there are these 6 possibilities where the eggs live, where x could be 1, 2, 3, or 4, and then y could be, oh no, y is a larger number than x. It's these ones. Whoops. My mistake. X has to be a large number than y has to be a large number than x. Okay, so I put not filled in circles here. Those ones are not allowed because x and y cannot be the same number. These are our 6 states. It also gives us a nice way to visualize that number 6 is a triangle number. 4 choose 2. And that's not a coincidence. It's a triangle number because the states live like this, right? Y is 1, 2, 3, 4. Okay, so these states are where the egg is on the far right, and these states are over here. This is the starting configuration, start and end. Okay, and the exploring that we did is that we went from 1 to x is 1, y is 2. I started moving y twice, and then I moved x. Then I started moving x twice. So I saw 5 things. I saw the start, 3 intermediate things, and then the end configuration like this. Right, okay. What are the possibilities? Could I have visited all 6 states? Let's draw on the possible moves. So what could I do? What could I do? So from the start, I guess you can move an egg. Moving an egg means changing one of these numbers, either x or y, for which egg you're moving. And it means like doing a move like this, where you, I guess, moving the y egg means increasing y by 1, keep x the same, and moving the x egg means increasing x or decreasing x. You can go either way along these lines, you go left or right. And now we've got an interesting conundrum. You cannot move diagonally, yeah, because that would change both egg numbers. So you've only got these square. So now it's looking, yeah, Zoe says this is great. Rowan says it looks pretty impossible, and you mean the same thing. Great news, this looks impossible. Yeah, there's different ways to explain this, but can you visit every stepping stone no repeats. Visit all 6 of them. Use these paths. There's no. Different ways to explain it. 1, 3, 2, 3. Now Mars is talking about a loop. Where's the loop? The loop is this bit up here. So it's true that there's a loop there, but if the graph looked like this, you don't have to use every edge. You have to visit every node. You don't have to visit every edge. So if the graph looked like this, then I could get around it by doing that or something. Maybe if there was some more graph before and afterwards, then I'd be okay. You don't have to use every edge. You're not forced to go around the loop. Yeah, and actually the odd nodes that Zoe's mentioned is also that's also to do with drawing all the edges. So I know the bit of math you're thinking about. I think. I'm psychic. I think you're thinking about the one where you try and draw all of the edges, and you can't draw all of the edges. That's true, because there are too many odd nodes. But again, I'm not trying to draw all of the edges. I'm trying to take all the photos. Equals visit all the blobs in this picture. Okay. Yeah, it's the bits not in the loop are awkward. They relate to the idea that if you're visiting the start and the end, they have to be the first and last things, which I think Miles said in chat at one point that because these things are kind of outliers, they've only got one way in. If your plan is to visit this blob halfway through your journey, then you're going to have to turn around and come back again, and you're going to visit this one twice. So that's got to be start and end, which is why I've labelled them S and E. Maybe the other way around, but symmetry, whatever. So I saw something about odd and even numbers, which is good. No, don't worry. Often, in graph theory, drawing all the edges is not a bad problem. It's the sort of problem that you meet in A-level decision maths, drawing all the edges. Visiting all the nodes is much harder. That problem is, it's really hard to decide if you can plan a route that visits all the nodes. It's called a Hamiltonian. Anyway, okay. The best solution for the next bit, to actually convince someone that you can't visit all 6, so you can kind of show them that as you try and explore, you can't visit nodes twice. So if you start going up this way from the start, you've got a choice, but then once you've turned, how are you going to get to that one because you've cut it off? Now you can't go in and out of that one. So you can try and build this argument where it's like, and if you go up, then you've cut off this one. You can't really go, because you're not allowed to go in and back out again. Oops, you visited that one twice. You're not allowed to do something like this because you visited that one. Nope, you visited that one twice. But the most convincing thing I saw was something about odd and even numbers. So let's see. I think what they actually said in chat was each thing moves twice, which moves an even number of times, which seems pretty convincing. Slightly stronger than the thing I had in mind, so I should think about that. My solution is to put some colour on this, to colour in the integer points on this graph. I'm going to keep going just because it's fun. I'm enjoying drawing circles. Shows you the pattern I'm doing, right? Some of them pink and some of them blue. Those are the 2 pens I've got easy access to. Kind of chessboard, right? If you do a chessboard pattern across this graph, then because the graph structure is really nice, it's squares and stuff, you'll notice that 4 of them are pink and only 2 of them blue. But as you move along these lines, you always alternate between pink and blue. Alternate pink, blue. I do it properly. Pink or blue. Uh-oh. if you're alternating between pink and blue, you'll start pink, blue, pink, blue, pink, blue, pink, blue, and end pink. But there's 4 pinks and only 2 blues, so you can't work it out. Graph colouring. Yeah, Thomas was telling me about the number of lines going from a point, but the challenge is not to draw all of the lines. The challenge is to visit all the points. So the number of lines isn't the problem, because we don't need to draw all of the lines. In the smaller version, and it feels silly drawing this with. No, I'm not going to draw this. It feels silly drawing the smaller version. Okay. So here's how this problem gets even better. If you've got more spaces, you get a larger. So I'm going to graffiti this picture now. If you were playing along with four spaces, this is a proof it's impossible. If you've got a larger grid, then things get slightly worse. If you want to try and visit these squares as well, then oh no, there are now even more majority pink nodes than blue nodes, so it gets even worse for you. So more spaces, 2 eggs is rubbish. You can't do it. 3 spaces, 2 eggs, easy. 4 spaces or more, 2 eggs, impossible. So then the fun thing to think about is a more realistic egg box, which has got 6 spaces and 3 eggs. It's not lost on me, by the way, that if I'd drawn a nice picture of an egg at first, then I would now have lovely pictures of eggs everywhere. That I do realise that I missed a trick to do a good job. 6 spaces, 3 eggs. Now we've just shown that 6 spaces, 2 eggs, which would be 15 photos, is impossible. 6 spaces, 3 eggs is 6 choose 3. I'm asking you to find 20 photos. So more eggs, more photos. This one is possible. So homework, I guess, because I think I'm going to leave it here in a minute, and we'll do some wrapping up. Homework, I guess. Find me a route through this maze, and it does feel like a maze to me. You've got this choice of directions about where you go, and you're supposed to. I guess with a maze, it's all about getting to the end, but for me, it's about the journey. It's about visiting every bit of the maze with no repeats. If your maze has got dead ends, that's impossible because you'll hit a dead end and have to turn back. These mazes that we're building have loads of paths, almost too many, right? For you to almost too many. It's not about exploring the paths. It's visiting the features along the way. Maybe that's a better way to say it. Maybe that's a better way to say it. To imagine this is like the room plan of a very interesting museum. A very interesting, very triangular museum. Oh, that's right in the chat. Yeah, room plan. Okay, I create a room plan, and it's got doors in here and linking the rooms together. And you would like to visit every room of the museum exactly once, no repeats. This is a much better way of saying the problem. No repeats. There we go. This is the version of the problem I should be doing. Here's a museum. You would like to visit each room exactly once, no repeats. Can you plan your way through? And then the answer is no, your chessboard, colour it in, and then it's 4 red squares, 2 blue squares, and you can't because you alternate. Even a bigger museum problem. The 6 eggs 3 the 6 eggs 3 things. The 3 eggs increases the dimension of the museum, so that the 6 egg version is kind of a problem. It's 3-dimensional. I will do the rectangle in a second, but I want to try and show you the maze that we've constructed here. We're asking you to visit each room, So there are 4 places you can go just in a straight line to start off with. So 1, 2, 3, 4. Kind of 4 like this, and then next to that there is another 3 rooms, and then 2 rooms, and then 1 room. Here's the maze that we're building. But then stacked on top of that, there's a kind of second story of the museum. Every room has got a staircase up to the cube above it, and the floor plan there is this. And then there's another floor up there, which is slightly larger, and then a floor up here, which is just 1 cube. Welcome to the Cube Museum. This is the top room up here. Do I love this? No, I don't love this. Isn't this obviously impossible because you can't visit the top room? What have I done wrong? Yeah, how are you going to get out of the top room, James? Yeah, I've done something stupid. Yeah, the upper stories don't work like that. The upper stories don't work like that at all. Oops. These two extreme ones. Okay, homework, draw the map. It's 3D, there's this kind of weird floor plan about how the configurations work, where these positions are X, Y, and Z. And they're in the range 1 to 6. I've done this before. It feels like the sort of thing I should be able to do. And you're back to equal number of eggs and spaces. So if you find a solution, you can then find another solution by switching the roles of spaces and eggs. This is beautiful symmetry you can do, where you, in each of your photos, you switch the eggs and the spaces. Drawing it out makes it too obvious, right? So there's the kind of link between these 2 problems, which I'll do in a second. So other version of this problem that I've made no progress with, the obvious problem that I would like to do is 3 eggs in an egg box that's the normal shape for an egg box. But the problem with me understanding this problem is that you still have this kind of 3D structure of what these coordinates could be. I mean, if you label the points 1, 2, 3, 4, 5, 6, then you have X, Y, and Z, which can move around. But now the moves are really confusing because an egg can add 3, so it's not just moving vertically. It's not just moving like nearby. It's moving 3, which is really messes up my graph. And then the question is, on each of these egg boxes, really the challenge is to find Hamiltonian path. Okay, I think it's kind of neat that adding an extra egg and requiring more photos makes the thing possible, even though the extra photos correspond to 3-dimensional extra complexity. Good, I don't know which arcade game you're referring to in chat. Help me out, chat. Yeah, just draw a Tesseract museum. Yeah. For 4 eggs in a 6 egg box carton, if you've got a 4th egg, then you should really start thinking about the spaces instead. And that kind of shows that the 4 Tesseract version. Right. Okay. I'm going to do 2 things. I'm going to fix this, and I'm going to tell you the link between these 2 problems. I'm going to do them in the opposite order. So both of these require you to move from one interpretation of the problem to a different interpretation of the problem. It's a skill that I'm trying to learn and trying to get better at. In this case, you have this interpretation of a sequence of letters corresponding to numbers, and the challenge is to convert that into this embedding into the integers. So when you initially meet the clicker problem, if you haven't just seen the Scrabble game, if you initially meet the clicker problem, you have this kind of concept that you're keeping track of a vector, and you need this idea to store it somehow inside the numbers, to do this kind of almost a change in how you're storing the information in the problem. Like you maybe you specify the information in the problem, you give things names and numbers, and then you try and operate on the numbers. Over here in my egg box problem, we had this kind of weird visualization of how the eggs were moving around, and we were thinking about eggs and spaces because that's what you can see. But then there was this kind of abstract interpretation to put some numbers on the problem and to map out what's going on, like how we thought about mapping out the prime values of these things and looking at the primes as on the Scrabble tiles. Once you've got that, you've got something different to visualize. I think there is like genuinely a difference for humans looking at the problem like this versus humans looking at the problem like this. Someone in chat said drawing out like that, and I think they mean like the hotel map down here, makes the graph theory a bit more obvious than the egg box problem. Though, and it's like though, which means like maybe that gives it away too much, right? So part of the fun of a good maths problem, I think, is that you change the way you look at the problem. We'll get there. So I'm not sure what the right way to think about these problems is really. This interpretation works really well for problems with 2 eggs because you get this nice flat picture that I can look at. With 3 eggs, this doesn't feel like the right way to think about it because this map that I'm trying to draw is really complicated. Yeah, so there's a configuration where you can only move, there's a start and an end. It's like exploring where the edges of the tetrahedron are. It's probably a tetrahedron. I have a feeling it's a tetrahedron. 3 eggs in free space, 6. It's like, yeah, okay. What's this corner then? So this is when this configuration here is, so it's egg, egg, space, space, egg, space, space, egg. So you could go back, you could start moving the second egg. Yeah, those are the only things you can do. So what's going on? What's above this? This is where you've moved egg, egg, space, egg, space, space, space. Oh, this is odd. Yeah, is there nothing above this row because you've only got 3 moves at most? Yeah, there's nothing above this row. So where's the next level of this pyramid then? Where's it go? Woo! Drawing maps of crazy things. I'm trying to imagine how could you possibly move. What am I doing? What am I doing? Am I just drawing this totally the wrong way around? No. Okay. Because this amuses me, the live stream is just going to keep going until I've got this map. I'm not sure I'm going to say anything clever, but I'm going to try and map out this problem. If you want to see that, you're welcome to hang around. But this is now going to go a little bit abstract, a little bit mumbly, as I try and do some live maths to make progress on my own problem. Jackie Weaver. 4 egg 6 spaces is the same as 2 egg 6 spaces because of Pascal's triangle. The same number of photos, right? Did I create this question? I think I invented it. What I really want more than anything is for somebody to tell me that it's equivalent to, like, you, I don't know, there's some other way of thinking about the problem that means, oh, it's just the same thing as finding differentiating a polynomial in 2 variables. It's just easy, right? If you think about it like this, that's what I want more than anything. I would accept somebody tells me, oh yeah, egg box, it's already a thing. Where do I find more interesting problems like this? There's interesting problems all over the place, and I don't just mean all over the internet. I think you can make up stuff like this if you keep asking questions until it gets hard, right? Or if you find something you can't do, then this came from trying to think about I mean, it came from bell ringing actually. I'd heard that bell ringing is I think it was like ringing the changes. I don't really understand bells. I refused to learn about bells. Instead, I tried to start drawing out these ideas that you have. You're kind of ringing you're going through all the combinations. This kind of idea, I'll make a puzzle like that where you go through all the combinations. I started drawing it out, and it looked like a egg box. 2 + 2 is 4. Welcome to the Oxford MAT Livestream. Right, I'm going to focus. What have we got? So we've got combinations like. We're going to abandon this, and we're going to go down to the 6 spaces 3 eggs problem. And as long as it takes, I'm going to form a 3D map of what this looks like in terms of this being like 1, 2, 4. So coordinates I've got like 1, 2, 3. That's the starting coordinates. That one can move to 1, 2, 4, and then 1, 2, 5, and then 1, 2, 6. I know that's changing Z, but I've drawn it in the kind of X direction, but that's okay. Over here, you could instead change that 2 to a 3. You could do the same thing here. 1, 3, 5, 1, 3, 6. And you can, these ones are related as well. So this is like the previous version of the problem. I'm keeping the X. This X's kind of fixed while I mess around with the other ones. 1, 4, 5. 1, 4, 6. And then down here or something is 1, 5, 6, which corresponds to having 2x way over here. Whoops. Way over here. 1, 5, 6. Okay. Now what can you do in the 1, 5, 6 thing? You've got 2 moves. Because in the 1, 5, 6 case, you can move the X egg, which moves you up to. So when can you move that egg? Oh, the next layer is going to lie on top of this bit of the pyramid. It's weird. It's offset. I expected it to be symmetric about the midline, but it's offsets over here. So okay, there's a 2, 3, 4, 2, 3, 5. No, 2, 3, 5. Yeah. So these ones you can increase 2, 3, 6, and down here 2, 4, 5, 2, 4, 6. I'm imagining the cases where you can increase the first number by 1, moving that first egg across by 1. They're all related together, of course, and they lie kind of on top of this bit of the picture. So I should draw lines like this. This is not going to be pretty. Right, and then there's another layer because I can move the eggs. Oh, well, no, which one's going to move? I can't move the first egg this time. I can move it over here. Down a little bit, please, for the picture. 3, 4, 5, 3, 4, 6, 3, 5, 6. And I'm imagining increasing that first number again to get up to the kind of next level of the pyramid. It is a pyramid structure. I think it's made of stacks of triangles. It's the kind of classic sort of triangle thing. And then the top corner lies up here. And that's the other end. That's the other end. It's a tetrahedron like this. Triangle. And then, where did this go? Oh, I had it in my mind for a moment there. And then a smaller triangle, and then a smaller, down. Smaller triangle. Draw that one larger. And corner comes down here, and then smaller triangle. Keep the overlap, and then a tiny little triangle. Down like that. Is that good visualization? Not sure. It's a tetrahedron like that. So in this world, oh my goodness. So now I think that's a map. That's what I wanted. We lost a few viewers, but we gained a map. Fun was the map we made along the way. And now I think you can explore it. You can't do, and this is the thing I love about this problem more than a lot of other things in this problem. You can't just do the first floor first and then move up to the next floor because the first floor is impossible. The first floor is the 5 spaces 2 eggs problem, and that's impossible. So your plan has to be to go upstairs at some point. Let's see if I can do it with like a laser pointer. So you can get along this corridor and then down here, and then maybe jump upstairs and come back and escape like this, and then go, oh, no, I regret, I want to go back, go upstairs, go across, loop back, and then go round and go upstairs, and then, oh no, I cut that one. Okay. So planning the route is really hard. Let's try planning, let's do a little bit of route planning. My first instinct is that I want to do things that are joined to one thing. I obviously need to do those as part of my route. Don't try and draw a kind of, what's that story with the maze and the string? I think it's the Minotaur one, Theseus. I'm going to draw a way through this maze, and it does feel like a maze. It feels like this thing's joined to 2 things. It's part all along my journey, so it's going to have to join up like that. Similarly, anything else joined to 2 things? No. So I've got a choice at the start. I can loop around, I can loop up. I've got loads of choice. Loads of choice everywhere. These things are all joined to 3 things. That thing there is joined to 2 things. So I wouldn't maybe have seen that, but this one's only joined to 2 things. So that's got to be part of my journey. And I guess this is a kind of symmetry, twisted kind of symmetry thing going on here. Where I've still got to plan a route through this middle bit, which really stresses me out quite considerably. I guess if you turn this way through the maze, then you have to turn this way. So let's give that a go. Through the maze like that. And now what? So you kind of on one path through the maze as well, not a kind of set of loops. It's got to have a start, a middle, and an end. Okay, I won't have to go just drawing it. Just join those and then go upstairs, come back. Yeah, I went too fast. Got too lost. Good. Okay, I think I might have to do this as homework. Actually getting through the maze. Yeah. Because now this is not very well connected. Yeah, that's only connected to 2 things as well. Should have seen that. Okay, so I think I don't want to do this, but I'm doing trial and error, right? This doesn't feel like maths at the moment. Or maybe I'll go upstairs here, and this way it's still connected to loads of stuff. Yep, I don't know. Oh, is this only connected to the 2 things? This is only connected to 2 things. It's got loads of corners. So then down, and then across, and do something similar from the other side. I don't know. Maze question for homework, I think. Save it for another time. The solution is out there on the web because I put this in a maths magazine thing. It's on somebody's blog at one point. I don't know, kind of guest blog thing where I put this on that blog. Good. Okay, I think I've actually gained viewers since I started the egg problem, which isn't this bit of the problem. I guess you're from the future. You're the people who skipped ahead half an hour, but you're like, oh, I'm so confused. How does YouTube work? Okay, so this is graph theory. This is a kind of graph that feels like a 3D structure, but you could compress it down to, graphs don't really have dimension like that. It's a kind of subset of a 3D lattice, I guess. I'm now just mumbling maths words. Right, okay, probably time to wrap it up, I think. Thanks for watching. You've got homework to solve my egg box problem and to come up with a way of formulating it. You saw how hard it was for me to map out the states of this problem. Some people in chat want to try this problem, which has got more connections because it's got more options on how you move each egg. So more of these long curved lines between random states. Like I think in their world 125 can move to 425, which is, oh gosh, not even on my board. Even more states. No? 245 it would be. So 125 can move to 245 like that. Woof. which worries me a lot. If we had a shortcut through here. And you can't move from 3 to 4. You can't move an egg off the edge. So kind of different connections. That's homework. I would still like to know which 4-letter, 5-letter word is best. I feel like I kind of cut off the conversation around about the time we got to area. Is area actually the best with 4 letters? And I would like to know about like 5 or 6 letters with this score distribution. I think that would be fun. I like saying fun things. Clicker problem. I feel like we solved all of the clicker problems we talked about. So if you can invent a harder version of the clicker problem, then do let me know. I've realised that chat got stuck. What's going on? Oh yeah, sorry, chat stopped. I think. Yeah, I think my chat moderator might have had to go home. Sorry. Git. Yeah, oh sorry. So there's people telling me about the maze while I was doing it. Sort of maze that you can start in. And, it's tough. Mapping out states is maybe not the best thing to do. Yeah, it doesn't feel like the best thing, right? There's a good, nice tetrahedron structure, which is good. Tetrahedron has 20 things in it, but not the best for solving mazes, perhaps. Maybe some sort of trial and error thing. Apparently, Claire Metcalf from the Step Interview Prep webinars gave us a shout out. Hooray! So they get one back again then. Shout out to them as well. I've worked with Claire on a bunch of step events, and I think they're really fun. Chat can now be separated messages with just whizzes and eggs in it. Good. Okay. Yeah, and we've done a good number of shout outs. I've got some 5-letter word suggestions over here. You haven't told me what they're worth, so I've got to work them out. Arrear is pretty good. Is that like when you're behind with rent? Eerie. I would love it if eerie was this. 5-letter words. Eerie's pretty good. You've got 3 E's in there. You've got an R and you've got an I. 35 times 8? I've got the calculator up from the other time. It's 280. What was arrear? What did you think arrear was equal to? 2, 3 squared. I'll work it out. 5 squared. It's a bit smaller, doesn't it? 225 times 2 is 450. Oh no, that's way more. Loads. So Erie might be the best. Erie's looking pretty good. Erie's looking pretty good. Right, brilliant stuff. Okay. I think I've run out of maths. That doesn't sound true, does it? Never run out of maths. I've checked my bit of paper for my set list, and there are things on my set list. Do Q&A. Don't make me record a 10-minute video right now. People in chat are going to notice that I've got 10 minutes left on the live stream until I hit 7. I haven't recorded your 10-minute video. There's the 1089 fact from Rowan. Let's see if I can remember the 1089. Let's see if I can remember the 1089 fact, just because. How does it work? It's something like you think of a 3-digit number, and you write it backwards, and you add them. Do you add them? No, you don't make it huge. Do you do the difference? Maybe you do the difference. Yeah, you do the difference. Do the difference? Yeah, you do the difference. And you keep going. No. You do something and you hit 1089. How does the 1089 thing work? There are multiple 1089 facts, right? People in chat are going to have to tell me. And then you add it to its reverse. Then you add it to its reverse. So the first time you subtract and then the second time you add. What a good 1089 fact. In chat we've got 321. So I guess the claim is that this always happens. And I can't remember if I've ever sat down and done the algebra for this. 495. Well, that's kind of interesting. Yeah, that's kind of. I kind of see. I see something. Okay. What's your other 1089 facts? Oh, 1089 times 9. We're doing facts about a particular number, but they're all supplied by chat. Chat wants me to work that out. Which is going to give the same number backwards. That'd be nice. Nice if true. Yeah, that's good. Are there any other numbers like that? This is one of those. This is one of those puzzles where each letter stands for a number. You've got to solve for them. What can we say about that? If A was bigger than 1, then this would be a 5-digit number, so A has to be 1. So, oh, whoops. So then I guess D has to be 9. So now, oh, can B and C be anything? No, because this is going to carry an ace over. And then, yeah, okay, fine. Maybe it's the only one that's like that. Ryan's got more facts in chat. One of them is that 1089 itself is 33 squared, which feels like a good fact. And then that if you square more 3s, you get something a bit like 1089, but with more 1s and 8s. Is it ETC? Does that keep going? Never runs into carrying issues? Maybe, yeah. Okay, got my eyes shut. That's going to help me work it out. What are you doing then? What are you doing? So those 3 things are a geometric series, right? Those are 10 to the n minus 1 over 3. I'm squaring them. So you're going to get 10 to the 2n over 9 minus. What am I doing? What am I doing? And then the claim is that that's 110. Doesn't look like anything. Yeah, don't understand that middle one. Good, cool. 496 is a perfect number. That's true. 496 is a good number. Did we see it? And then we nearly saw it. It was 495 along the way. 496 is lovely. It is. Oh gosh, is it? What's it? What's this prime factorization? Is it 32 times something? I think it is 32 times something. Tries to factorize. I'm too sleepy for this. Oh, come on, James, it's 4 less than 500. Use your 4 less than 500. So you divide it by 4, and you get 124. Then you divide it by 4 again, and you get 31. Yeah, fine. Okay, it's 16 times 31. All the perfect numbers we know are of that form, and by that form I mean 2 to the something, then 2 to the next thing minus 1, multiplied together. We don't know any perfect numbers that aren't of that form, but no one's proved it. Hello, welcome to the stream. We've entered the killing time bit of the stream. Somebody asked me about my tablet, which I get asked about a lot. I'm going to write the brand's name. Tablet FAQ. Hang on, let's formalise this. This deserves this whole screen. Tablet FAQ. Is it a mouse? And the answer is no, my handwriting's just this bad, even with help. What is it? It is I got it on Amazon and it was cheap. And I got it about 4 years ago in the pandemic, so I don't know if that's still a thing. It's one of those brands on Amazon where it's capital letters. Is it good? And then it's okay. The pen has got buttons on it for like clicking, which is kind of good. You sometimes do want to click, but quite often you don't want to click. And combined with Miro, that makes that's the reason I sometimes wiggle the screen around, because my fingers accidentally press one of the click buttons. That's my main annoyance with it. Is it a tablet with a screen? No, it was very cheap. Is it a Wacom? No, sorry, it is a Veek thing. Yeah, why not a touchscreen computer? I thought the cheapest thing. Does it have pressure sensitivity? That's a good question. It's not an FAQ. I think technically yes. It was advertised as having pressure sensitivity. I've never really worked out what that means. I don't think Miro supports it, which is where I'm on Miro at the moment. Why not a touchscreen computer yet? The university has £1 billion, right? Why am I using the thing? I've just looked at the do you ever replace the nib on the pen? // why is it so loud? Huh. I should find out if I can change that. Might improve my life. They have models? Of 1 million? Yeah, I bet there are. The way you said James in capitals made me think that I was the name of a brand on Amazon because of five letter in capitals. So eggs, yeah, if you solve the egg problem, or if you consume the egg problem, thus solving it in the Gordian knot style of there is no more a problem, then you can get in touch. There's a contact form at the bottom of the Mat Live website. You could email mat-info. The contact form goes straight to me though. If you want to tell me about eggs, the things I would really like with the egg problem again, are maybe you've solved the thing with 6 spaces and 3 eggs. That's fine. I think I have too. So you can show me if you like. Maybe you've got a great way of thinking about the problem. That would be really nice. I'd like that a lot. Maybe you've realised its equivalence to a problem you've seen somewhere else. I would like that a lot, indeed. You eat 6 quail eggs but 2 chicken eggs a day. Okay, how do you keep track of them? Do you need a system? Because you might be considering buying 2 clickers. Someone who's eating 6 quail eggs a day probably thinking about getting a special quail egg counter, but by God, a strategy for you. Does my tablet have 6 buttons on the left hand side? I'm not sure I'd call them buttons. It's like plus plus, rectangle plus plus. Are people trying to buy my tablet? To be clear, I did no research about tablets. Let's put some more FAQs on the screen. I've got to not get sued as well. I think it's a good tablet. I said it's okay. Does it work out of the box? And the answer is sort of. Straight out of the box, you plug it in, you get some features, but not all of the features. There exists software that you can install on your computer that lets you give you features like I've got 2 screens, so deciding which screen it's connected to is a software feature that I can only use if I install their software. Does it have 6 buttons on the side? The buttons look like this. The buttons look like plus, plus, long rectangle, plus, plus. They're not physical buttons. They are. This is the weirdest way I've tried to do a product demo. There we go. This is like shiny. And some of those, the problem with not having physical buttons is also that sometimes my wrist presses them. That one does like a zooming thing, which I don't like. I disabled all the other buttons. Or did I? No, I did not. That one does grab. What's that one do? I don't know. Ooh, blimey. Oh, right, okay. Well, that's done something. Good thing I never pressed that one during a live stream. Turns out one of the buttons is preset to reload the page, like F5 or something. That's really... Please describe the tablet's appearance in detail. Is a black rectangle. Black rectangle. Right, okay. Keep talking and no one explodes. Down the left, shinier than the rest. Most of it's matte black, but the left bit is shiny and says "Veek" in the bottom corner. The top bit around the top bevel and a little bit of the just the top bevel is slightly textured to have a kind of grid-like texturing along the top. And most of the space is just a blank matte black object. It's like the most object that I own. It is a rectangle of matte black plastic. The matte black plastic has 4 very faint corners marked on it. What is this live stream about? Yeah, I don't know. It's normally a maths live stream, but we've got a bit of time left. I said I'd do 1 hour. Everything after the 1 hour has been extra. And yeah. Everything after that's been extra. We're doing a bit of FAQ about tablets. We're doing a little bit about clickers again. Someone's been in chat that's got a lot of quail eggs. Oh, brilliant! The number of messages with egg is greater than the number with James. That doesn't always happen. Someone has posted an Amazon link. I think I'm helping somebody buy an Amazon link. Let me just check. Yeah, that's it. Yeah. Also, it turns out I'm logged into Amazon. That's it. Congratulations, you've identified exactly my tablet. You last purchased this item on the 11th of June 2020 because I did the very first couple of episodes of the MAT livestream with a mouse and it was awful. And after a couple of episodes in the middle of June 2020, I bought a tablet. How much are they charging for it now? It's 40 quid. Yeah, you got it. Anonymously, you got it. You win a prize. Not an actual prize, but you win the pride of... I think that's the first time someone's linked me to my own graphics tablet. Can I call it a graphics tablet? That's what they're calling it. Yeah. What sort of live stream is this? It is a maths live stream that has been running for a few years by someone who doesn't really know anything about tech, but still enjoys going online and chatting to people who like maths, either about maths or about tablets. That's brilliant. I love that a lot. That was all worth it. The last 10 minutes of official Oxford content where we worked out how one person could purchase exactly the tablet in front of me. Let's do some really good content. Something I became worried about with this this Scrabble problem is that the words that you generate have way too many E's in. As you work through the numbers 1, 2, 3, 4, 5, you're hitting like 2 has got an E in it. 4 corresponds to the word EE, which I don't know. It's just so many E's. Every other number is reserved for words with E's in. And there's just nowhere near that many E's actually in the English language. So, sort of slightly hard question is, how do you actually set up the distribution of points to match? Or maybe the question is sort of the other way around. Like, if I've got these prime numbers associated with my letters, and I look at the first 1,000 words, so the first 1,000 numbers, E, up to whatever 1,000 is. I guess 1,000 is loads of E's and R's because that's how you make 10. 1,000 is re, E, 3 E's and 3 R's. Up to 1,000, there are quite a lot of E's in there. More than 500 E's overall. The kind of majority. No, not the majority. Maybe not the majority. There's a lot of E's. Actually, E makes up less than 50% of the letters that you see in the English language. How many E's do you see? Which is a kind of stupid way of saying how many factors of 2 are there in 1000 factorial. But again, it's nice having these different ways of thinking about the problem, right? How many E's are there if you convert letters to primes and put them together? For math songs, you can go to Grant Sanderson, 3 blue, 1 brown, because is there anything that guy can't do? Grant Sanderson recently uploaded a math song that, infuriatingly, he wrote the lyrics for it, and it's funny, and it's very 3 blue, 1 brown, and it's very clever. Brilliant. Oh, that's the song. At the RI in London, I don't know if they've still got this, but in the RI in London, they have a periodic table song that plays. You press a button, it plays the song. The elements are in a kind of random order, they're not in the order on the periodic table. And as the song plays, a big periodic table on the wall lights up which element has been named. They're in the order of the Tom Lehrer song. That's it. So the Tom Lehrer song plays, and you, like one of those reaction games, you have to tap the elements as they come up in the Tom Lehrer song. It's brilliant. I don't know if that's still a thing in the RI, Royal Institution, where they do Christmas lectures. But when I was a kid, that was a solid entertainment thing that you got to do the reaction game. But mostly it's around memorizing the order of the elements in Tom Lehrer song. One of my friends at the time could do it really well. Right, good. Okay, that'll do. It's 7 o'clock. I think we have successfully escaped from talking about maths. I really want that to be true now. I'm gonna go try and get to the RI. Okay, let's put the RI on that square. Look, I remember their logo looks like these as well. Everyone gets the RI. Learn about some chemicals. Okay, thanks for watching. We're going to be back in approximately 2 weeks for, yes, it's 2 weeks, I think. 2 weeks' time for some interview question fun. I'm going to talk about some interview questions. Have a nice evening, and see you around. Bye.